When I look at your heavens, the work of your fingers, the moon and the stars which you have set in place, what is man that you are mindful of him, and the Son of Man that you care for him? The Bible tells us to study nature in order to learn about God. As Christians, we are supposed to participate in the activity of science, and when we do, God's attributes will be revealed to us. One of the attributes we see when we study nature is that the creator of the universe cares for us. So much, in fact, that the structure of the universe is perfectly fine-tuned and has been from the beginning, so that advanced life can exist on our planet at this moment. The psalm I read at the start, Psalm 8, describes this perfectly. Astrophysicist Luke Barnes puts it this way: fine-tuning suggests that at the deepest level that physics has revealed, the universe is well put together. The whole system seems well thought out, something that someone planned and created. Through science, we can detect the incredible planning and design of the universe, which shows us how much God cares about us. The more we learn about how fine-tuned the entire universe has to be for us to exist, the more we see the love that God has for us. Science confirms what Psalm 19 tells us. The heavens declare the glory of God, and the sky above proclaims his handiwork. Day to day pours out speech, and night to night reveals knowledge. Again, the more we discover about the universe, the more we find that the laws and conditions are perfectly set up so that advanced life can exist and thrive on Earth at this moment. This is what we mean by fine-tuning, and it refers to the various features of the universe that are necessary for the existence of complex life such as us. These features of the universe that are fine-tuned for life include the initial conditions and brute facts of the universe as a whole, the laws of nature, or more specifically the numerical constants present in those laws, as well as the structural features of the universe, things like a planet's distance from its host star. The basic idea of fine-tuning is that certain features must fall within a very narrow range of possible values for chemically based advanced life to be possible. A good analogy is a key in a lock. A key will open a lock if it is fine-tuned to the correct shape and size. There is a narrow range of possible sizes for the key to be able to work. Too small or too big, and the key won't open the door. A key can be made maybe 0.05 millimeters too large or 0.05 millimeters too small and still open the lock. So if the average key is 5 millimeters wide and can only vary by 0.05 millimeters to still open the lock, a key must be fine-tuned to 1 part out of 100, or 1 part out of 10 to the second. Many of the constants I will talk about in this video must be astronomically more fine-tuned than this, most beyond comprehension. Keep the key example and the next examples in mind when I present just how finely tuned the constants have to be. So, for the key, 1 part out of 100 was 0.05 millimeters when compared to the 5 millimeter width of the key. If we jump up to 1 part in 10 to the 10th, well, that's equivalent to 0.02 inches if we compare that to the distance from the Earth to the Sun. 1 part in 10 to the 20th is a distance smaller than an atom when compared to the distance from the Earth to the Sun. And if we go up to 1 part in 10 to the 40th, well, that's a distance smaller than an atom if we compare it to the distance across the entire universe. So this video will focus on the fine-tuning of the cosmic constants, the initial conditions, and the brute facts present in the universe that are necessary for advanced life to exist. So let's look at what Stephen Hawking has to say. The remarkable fact is that the values of these numbers, the constants of physics, seem to have been very finely adjusted to make possible the development of life. For example, if the electric charge of the electron had been only slightly different, stars either would have been unable to burn hydrogen and helium, or else they would not have exploded. Nevertheless, it seems clear that there are relatively few ranges of values for the numbers that would allow the development of any form of intelligent life. Most sets of values would give rise to universes, although they might be very beautiful, would contain no one able to wonder at that beauty. He then added that one could take this as evidence of a divine purpose in creation. Paul Davies, physicist and cosmologist at Arizona State University, said, quote, "Scientists have long been aware that the universe seems strangely suited to life, but they mostly chose to ignore it. It was an embarrassment. It looked too much like the work of a cosmic designer. So, what is it that we are finding that demonstrates that the universe was designed for life to exist? We will begin with the constants that we measure that determine the strengths of the fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The gravitational force constant is the thing that determines the strength of gravity, the large-scale attractive force that holds people on planets and holds planets, stars, and galaxies together. If it were too weak, then planets and stars could not form. If it were too strong, then stars would burn up too quickly. For life to exist in the universe, the gravitational force constant must be fine-tuned to 1 part in 10 to the 60th. Now, to imagine what this means, 1 part in 10 to the 60th, that would be equivalent to 1 dime's worth of mass when compared to the mass of the entire universe. Number 2, the electromagnetic force constant. This determines the strength of attraction and repulsion between charged objects. The small-scale attractive and repulsive force which holds atoms, electrons, and nuclei together. If it were much stronger or weaker, we wouldn't have stable chemical bonds. The electromagnetic force constant cannot vary by more than 4% for life to exist. Now, the 2 most common forces that we experience on a daily basis are gravity and electromagnetism. Their strengths must be highly fine-tuned, but also how they compare to each other has to be highly fine-tuned and is crucial for life. The ratio of the strengths of the electromagnetic force and the gravitational force constant needs to be very close to 10 to the 40th for life to exist. The strong nuclear force. This is the small-scale attractive force that holds nuclei of atoms together. Because of the electromagnetic force, positively charged protons should repel each other, but the strong nuclear force is able to overcome this repulsion and hold the nucleus together. If this force were weaker, the universe would have far fewer stable chemical elements, eliminating several that are essential to life. Not only does it need to be fine-tuned within 0.4%, but the distance over which it operates is unusual and highly precise as well, operating only over tiny distances within the nucleus of the atom. Now, the distance over which the strong nuclear force operates is highly unusual. Electromagnetism and gravity both operate over huge distances, but the strong nuclear force only operates within the nucleus. The weak nuclear force. This force governs radioactive decay. If it were much stronger or weaker, life-essential stars could not form. Astronomer Martin Rees estimated that a change in the strength of the weak nuclear force by about 1 part in 10 to the 4th, relative to the strength of the strong force, would have prevented supernova explosions, which allow heavier elements to find their way to the planets. Without these supernova explosions, key heavy elements would be unavailable for life. Now, our current theory for how our elements are formed is that they are created during the fusion that takes place in stars. The heavier elements are only formed when stars explode. We think that the elements we currently observe needed at least 3 generations of stars to form. They needed to experience fusion for hundreds of thousands to billions of years and then either explode or collapse to form neutron stars to create heavier elements. Only in supernova explosions and in colliding and exploding neutron stars do the heavier elements get created. The explosions also distribute the elements throughout the universe. This is all connected to the weak nuclear force because a fine-tuned weak force is necessary for supernova explosions to take place. A related brute fact regarding the weak nuclear force is that it is different from the other forces. The weak force is involved with a particle called a neutrino, and this neutrino makes the weak force asymmetric. This is different from the other 3 forces, which are all symmetrical. This strange asymmetric property of the weak force is necessary for life to exist in the universe. Along with the fine-tuning of the 4 fundamental forces, the rate at which the universe expands must also be extraordinarily fine-tuned. The cosmological constant controls the expansion speed of the universe. It refers to the balance of the attractive force of gravity with a hypothesized repulsive force of space observable only at very large scales. It must be very close to 0, that is, these 2 forces must be nearly perfectly balanced. To get the right balance, physicists now commonly agree that the cosmological constant must be fine-tuned to something like 1 part in 10 to the 90th. If it were just slightly more positive, the universe would fly apart. Slightly more negative, and the universe would collapse. The cosmological constant has to do with two crucial conditions necessary for life: the thermal connectedness of the universe and the flat geometry of the universe. Both of these factors affect how clumpy the universe is. If it is too clumpy, if large amounts of mass are too close together, then there are too many gravitational perturbations and too much radiation, and both are deadly for life. If all the mass is too spread out, then there won't be enough heavy elements necessary for life. If the geometry of the universe was not flat, the universe would have either collapsed back in on itself, or it would have expanded too quickly for life to form. Another fundamental feature, a brute fact of the universe necessary for life, is the mass of the up quark. The mass of the up quark must be finely tuned to 1 part in 10 to the 23rd. And that's relative to all the possible masses that a quark could have. If the mass of the up quark were this tiny fraction larger or this tiny fraction less, there would be no carbon and therefore no life. Other brute facts of the universe necessary for life to exist include the ratio of masses for protons and electrons, the velocity of light, and the mass excess of the neutron over the proton. If the ratio of the mass of the proton compared to the electron were slightly different, building blocks for life such as DNA could not be formed. If the speed of light was faster, stars would be too luminous. If it were slower, stars would not be luminous enough. If the neutron was a bit heavier than it is when compared to the proton, there would be too few heavy elements for life. And if the mass of the neutron was closer to the proton, stars would quickly collapse as neutron stars or black holes. In addition to the physical constants and fundamental forces, there are initial or boundary conditions which describe the conditions present at the beginning of the universe. Initial conditions are independent of the physical constants and the masses of particles. One way of summarizing the initial conditions is to speak of the extremely low entropy, that is, a highly ordered initial state of the universe. This refers to the initial distribution of mass energy. Physicist Roger Penrose estimates that the odds of the initial low entropy state of our universe occurring by chance alone are on the order of 1 in 10 to the 10th to the 123rd power. Now, this ratio is vastly beyond our powers of comprehension, and it begs for an explanation as to how it can be so precisely fine-tuned. There are also a number of striking effects of fine-tuning downstream from the basic physics that also illustrate just how profoundly fine-tuned our universe is for life to exist. I will mention just 2 of these effects: the current distribution of structures in the universe and the amount of hydrogen-helium present in the early universe. Now, these effects are not independent from the parameters like the constants I previously mentioned, but they do help illustrate the idea of fine-tuning. Life is only possible right now with the universe at its current size and age. The initial conditions and constants dictate this size and dispersion of structures in the universe. Stars are currently separated by an average of about 400 light years. To put this in perspective, imagine that a star is shrunk down to the size of a cherry. If stars were this size, then the average distance between a star and the next star would be 13,000 miles. Now, this has not always been the case, so only at this precise moment can advanced life exist. If stars were closer, gravitational disturbances and stellar radiation would make advanced life impossible. If stars were more widely dispersed, which they soon will be, planets wouldn't have the necessary heavy elements for life. 2 specific heavy elements, uranium and thorium, both of which are necessary for advanced life, are only present on Earth at the current concentration for life because our solar system just happened to form at the time when uranium and thorium concentrations were at their maximum, when the universe was slightly more than 9 billion years old. The amount of hydrogen and helium present in the early stages of the universe was also crucial to life. 24% of the hydrogen by mass fused into helium during the first few minutes of the universe's existence. This determined the type of stars and therefore also the type of elements that could be produced by those stars. Life on Earth requires highly specified abundances of specific elements that depended on the number and types of stars in the universe, which in turn depended on the amount of hydrogen and helium in the first few minutes of the universe. Now, as I have demonstrated, the universe is extraordinarily fine-tuned, beyond our comprehension, for advanced life to exist. Why is a question that needs to be answered, especially since we are discovering at every time and at every location that the universe is fine-tuned for the existence of advanced life to exist on Earth. The next few videos will show you that advanced life cannot just exist anywhere or at any time, and in fact, the structure of the universe demonstrates that the Earth's location and the Earth itself has been perfectly set up for advanced life. As we learn more about our universe, it becomes increasingly clear that everything was set up and designed for advanced life to exist on Earth. This, of course, doesn't prove that a cosmic creator exists, but it certainly is compelling evidence for a mind that planned and designed the universe for our benefit. For God's attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world in the things that have been made. The Bible tells us to study nature, to learn about God, and when we do, we can see God's incredible power, his ability to design and set up the entire universe for us to exist on Earth. The entire universe has been set up from the very beginning for us, for you, to exist on Earth at this moment in time. The Christian worldview has an explanation for this. Remember, I opened the video with Psalm 8. When I look at the universe, I wonder, what is man that you are mindful of him? God cares about us, and because he loves us, he provided a home for us where we can live and thrive. The fine-tuning we find at every level, at every location, and at every time in the universe demonstrates God's care for his people. Psalm 136 connects God creating with his love for us. Give thanks to the Lord, for he is good, for his steadfast love endures forever. Give thanks to the God of gods. Give thanks to the Lord of lords, to him who alone does great wonders, to him who by understanding made the heavens, to him who spread out the earth above the waters, to him who made the great lights, the sun to rule over the day, the moon and stars to rule over the night, for his steadfast love endures forever. God's steadfast love and his reasons for creating the universe and creating us culminated in the person of Jesus. Jesus came to earth to mend the fractured relationship between us and God. Because we constantly break God's law, we are separated from God. So God provided a way to repair this relationship through the person of Jesus. God, the creator of the universe, wants a relationship with you, and you can have that relationship through the person of Jesus. The universe is exquisitely fine-tuned for life, for us to exist. As Stephen Hawking pointed out, this can point us to the person of God and demonstrates how much he cares about us. He cares about you so much that he wants to have a relationship with you, and you can have that through the person of Jesus.